Good morning and welcome to lesson 65 on similar figures. Now you're probably wondering why you spent so much time in the last lesson looking at ratios and proportions. Well, this is where it comes in. Remember that triangles that were the same had congruent angles and congruent sides. Triangles that are similar are triangles that have congruent angles but sides that are in similar proportions. Okay, and you see an example of that here. There are two triangles. Angle B is the same as angle E. A is congruent to D. C is congruent to F. But clearly, the side AC is shorter than DF. AB is shorter than DE, and BC is shorter than EF. However, they are in the same proportion. And how do you know that? Well, simply by taking the ratio of 12 to 6, you get 2, 10 to 5, you get 2, 8 to 4, you get 2. So if you can take any pair of corresponding sides here, here, or here, and you get the same ratio. And that's explained here. Now, clearly, two shapes that have congruent angles aren't necessarily similar, and that's obvious. Okay, in this example here. So really you have to find correspondence between the sides. And you may have a certain proportion here and here which is the same, but which won't be the same as these ones. In fact, the proportion between these two sides, AD and EH, appears to be 1, and BC appears to have the same length as FG, so that's a proportion of 1 as well. But this one to this one would be 1/2 probably as this. So they're not the same all around. Whereas in this example, the proportions are always and everywhere the same, no matter which pair of corresponding angles is taken. So you can set up a proportion with any two corresponding pair of sides, and the fractions and the proportions are guaranteed to be equal. Now, of course, if the two shapes are proportionate. Now, what else have we got here? They also say you can flip. I mean, in this example, we took big over small. We could take small over big. We just have to be consistent. That's pretty obvious. It probably, let's look at the definition first. So the definition of similar figures: if the vertices of two polygons can be paired so that corresponding angles are congruent and the lengths of corresponding sides are in proportion, then the polygons are similar. Not congruent, but similar. Now, before we get into the symbols, just a note, it probably has not escaped your attention that we're defining similarity as, the two pairings of any two angles producing similar proportion. But note that there are similar proportions between this and this compared to this and this, or this side and this side compared to this side and this side. For example, 12 over 8 is 1.5, 6 over 4 is 1.5. So that's also an interesting feature, but that's not covered here, but no doubt is coming. So how do we indicate this when we write out proofs or read our exercises? Well, basically, remember this one, the equal with the squiggle on top, indicates congruence. Similarity is indicated with the squiggle and no equal sign. Okay, so equal, I guess, is a strong symbol. It indicates true congruence, whereas this indicates similarity. So triangle ABC from the other page is similar to triangle DEF. And of course the sequence of the vertices is important. So ABC is lined up with D, E, and F respectively. And that's indicated here. So we know that angle A is the same as angle D, B is the same as angle E, and C is the same as angle F. So these angles go together. So you have to respect the sequence. This is a naming convention that was used earlier. Okay. And more on that up here. So I hope that's helpful. Have a great lesson. Bye.